Before we dive into filling out the breeding scheme spreadsheet, it's crucial to have a clear understanding of how your breeding scheme is structured. A good way to start is to sketch the outline of a breeding scheme. I'm going to do it by hand at first, so you can see you don't need much to begin with. Let's assume we're leading a Category 1 wheat breeding program. We always start each breeding cycle with the crossing block. After making the crosses, we work through generations from F1 to F8, which is where I'll stop for this tutorial. Now, what are the key activities at each generation? From F1 to F3, there is screening and selection of individual plants within families. In F4, material is planted in hedgerows and undergo marker-assisted selection. In F5, there's no selection. We simply multiply the seeds for field trials on F6 and genotype the lines. F6 is when the lines enter early stage yield testing. New parents are selected here. From F7 onwards, they move into late stage yield testing. And there you go. Now that we have the basic outline sketched, let's take this to the computer so we can fill in more details. How many parents are in the crossing block? Where do they come from? How many crosses are performed? Is there a mating design? So I'm adding here that we performed 20 crosses. There's 15 parents in our crossing block. They all come from F6 within the pipeline and we cross them at random. On average, how many individuals are selected in each stage? I know these numbers realistically fluctuate every year, but usually there is a number of individuals in each stage that is representative of a breeding scheme in most years. For example, if you know in F2 you generally select between 1,900 and 2,100 individuals, then 2,000 is a good representative number of individuals selected at that stage. Here in F6, besides advancing material, we are also selecting for recycling, as the parents for the next cycle are selected from this stage. So I make sure to differentiate these two types of selection. What traits are being selected for at each stage? There's no selection in F5, but we are genotyping though. What density? How many markers? In F4, we are also genotyping for marker-assisted selection. It's important to know how many markers for each trait, as I already indicated here. What's our yield trial design? Number of locations, experimental design, number of replicates per location, how many checks there are they spatial or temporal checks? What selection values are we using? Only visual or marker scores, or some kind of analysis? For example, from F6 onwards, we estimate breeding values using genomic information, so we add here that we use GEBVs for selection. We also need to differentiate between values used for recycling and values used for advancement. In this example, they are the same, but this might differ. Which selection method? Independent culling or a selection index? And here, you should also differentiate between advancement and recycling. Let's say for advancement we use independent culling, and for recycling we use a desired gains index. And there you have it, the outline of a breeding scheme. Now that we're clear on the structure, we're ready to start filling out the breeding scheme spreadsheet. In the next video, we'll use this outline to complete the sections on breeding population, population structure, and seed and material increase in the spreadsheet.